Welcome to Unit 2, Lecture 3, Section 5.3. In this lecture, we're going to focus specifically on human population growth, and we're going to bring in those age structure diagrams that I mentioned in lecture 5. Or the first lecture for this section. Okay, because they really more pertain to human populations than animal populations. Learning objectives for this lesson are: describe the change of human population size over time. Explain why population growth rates differ between countries. Over the course of time, the size of the global human population has been increasing. The human population is getting bigger, okay? But it's important to note, so while the size is increasing, the rate at which it's increasing is actually starting to slow down. So if you can look here, let me find a different color. Okay, if you can look here, right, in 1959, okay, we had 3 billion people. Right? Each person is 3, so we had 3. Okay, so we ended up getting 6 billion people in 1999. So that's 40 years. We doubled the population size. Okay, and now, so to get to 12 billion people, all right, this graph here at 2042 still only has 1, 2, 3, 4, 5, 6, 7, 8, 9. That's only 9 billion people. Okay, so in 40 years, earlier in the 20th century, we were able to double the entire world population, but from 1999 to 2042, which is, if I do some quick math, is like 43 years. Okay, so in 43 years here, we still haven't doubled the world's population. Okay, we haven't doubled it again. So so the rate of that population growth is actually coming down. Even though the size of the population is getting bigger, it's not getting bigger as fast, is what that boils down to. Populations go through this thing called a demographic transition. And over the course of a population's lifespan, if you think about an entire population, so we could think about individual countries, okay, we could think about continents, we could think about geological ages, whatever you want to discuss. But populations go through a demographic transition. And what that means is there's 3, sometimes demographers will give it 4, okay? There are stages to what's happening in a population. So in a stage 1 population, the birth and the death rate are actually both very high. So the population is actually staying about equal, okay? Because almost as many individuals who are being born are also dying. This is why back in the day you would have families that had 20 kids, okay? Or they would, or whatever, because for many reasons, but there would also be a increased infant mortality rate or child mortality rate. And then, so stage 2 happens when that death rate, you see this blue line here, this blue line actually starts to fall off. But the red line, which is the birth rate, actually remains high for quite a while. So what generally is happening with these populations is they're increasing by a lot. And this is where we actually see the most population growth, because the deaths have actually tapered off. Okay, and then stage 3 is when that birth rate actually falls off again. That birth rate actually falls off. Okay, and now once again, birth rate and death rate are about equal. They're just a lot lower than they used to be because modern medicine, sanitation, housing, okay, we generally, color was really light. Okay, and so once again, the population growth is about equal again, because births are equaling deaths, and they're actually at a very low rate. So this is actually where the United States is. We are in stage 3, or some would put us in stage 4. What happened is our birth rate is actually below our death rate. There's a lot of families that are having no children. There's a lot of families that are only having 1 child. Okay, some families are only having 2 children. 2 is what would actually be necessary to replace yourself in the gene pool. Okay, so there's many reasons why that's the case, but in the U.S. we're in a stage 3 situation. And last but not least, I wanted to talk about age structure diagrams. Age structure diagrams look like really kind of complicated bar graphs. Okay, so you basically have 2 bar graphs smashed up with each other in this center line. So there's this line here, and you can see here we've got blue on one side, green on the other side. So on the blue are our males, the green is our females. Okay, so for each one of these graphs, we got males on the one side, females on the other. Males, females. And what these bar graphs are showing is basically giving us a number of individuals in the population and how many of them are males and how many of them are females. So we break the population into percentages, okay? And then what scientists or demographers or even marketing analysts would use this if they're trying to figure out when to run a certain advertisement or where to put a certain advertisement, or if do we need to add schools, do we need to add hospitals, do we need to add assisted living homes, those kinds of things. So this is kind of part of that for marketing or development. So what it does is that scientists or whoever would look at this information and decide what's going to be happening to the population in 5, 10, 15, 20 years. So one of the things to look at here is 10 to 14. Okay, here's the 10 to 14 range. Okay, 10 to 14, in that stage, that's going to be the next generation of parents within 5 to 10 years, and depending on exactly which country it is, that comes sooner than others or whatever. But in the next 5 to 10 years, those individuals are going to be the ones that are having babies. So the more people you have in this age range means the more babies that are going to be being born in the next 10 to 15 years. Okay, and so what populations demographers do is, depending on which country or what we're looking at, but for this age range, that tells us that either we're going to have rapid population growth, we're going to have negative population growth, or we're actually going to have a steady growth or no growth, really, and equal. So if you look at this one graph here, the first one right here of Niger, okay, you can see there's a lot more individuals at the bottom, okay, and less individuals at the top. So what does that mean? That means that these individuals at the bottom are going to survive and reproduce, and this is going to end up resulting in a growth in the population, potentially pretty rapidly, as these 10 to 14-year-olds come of age. The United States, okay, if you can see, a lot smaller number, because it's a little skewed, because here we go all the way out to 20% at the bottom. Here we only go out to 8%. Okay, and it's a lot more even all the way up. Right? So that means a slow or no growth situation for the most part. All right, so these 10 to 14-year-olds are about the same as the people who are having kids now. You would say let's say the 20 to 29-year-olds in this range. Okay, there's about the same amount of the population. So we're not really going to have an influx of new births. Okay, then compared to Japan here, where the 10 to 14-year-olds are actually lower than the older generations. All right, and you can see, so this is actually a negative growth. So the Japan population is actually in a state of decline. All right, that's it. Okay, we'll talk a little bit more about human population in class. Hope you have a great night. Talk to you later. Bye.